Alright students, we're here and we're going to dive right into the Unit 6 Non-Rigid Transformation Similarity Review. Alright, put your thinking caps on, put your writing shoes on. This is going to be dense, probably a little long, but remember it's a review. It's going to be thorough to help you try to prepare for the test, and that way we can do our best. Alright, and plus when you guys study, it should always be a little bit more work and a little bit more effort than a typical night. Alright, so anyways, the pre-image is the small pigeon and the image is the big pigeon. All right, is this a reduction or enlargement? It's an enlargement. All right, remember we're getting bigger. All right, it's an enlargement. Furthermore, this is the center of dilation. All right, think of like the nozzle of a balloon. That's the stretching point. That's where we're getting bigger or smaller from, is the center of dilation. So what's the scale factor? Remember, the scale factor is equal to the final length over the original. So this isn't meant to be a trick question, but some of you guys might say, oh, well, the final length is 8. No, that's false. The final length is 12. All right, don't get confused. All right, it's always from the center of dilation to the image, the final image. So in this case, it's going to be 12 over 4, which reduces to 3. So that's the scale factor there. All right, this next one, same kind of problem, just repetition. The pre-image of Homer Simpson is the big Homer Simpson. All right, so this is pre. So even if you write pre and final, all right, remember we can call the pre-original as well. Those are interchangeable. All right, so this time we got a reduction. All right, Homer Simpson's getting smaller. All right, and then what's the scale factor? Again, the final length is 5. Remember, we always want to be back to the center of dilation. The scale factor is 5. Ooh, let me write it like this, actually. The scale factor is final over original. In this case, 5. And the original length is 15. So 5 over 15, which reduces to 1/3. All right. And since this is less than 1, remember, another thing to think about, reductions, the scale factor, K, is between 0 and 1. Can't be 0 because the shape would disappear. Can't be 1 because the image would stay the same. But if the scale factor is between 0 and 1, it's a reduction. And if we look back up here to enlargement, if K is bigger than 1, that's when it's an enlargement. All right, just some ways to tell by looking at the number. All right. Figure ABCD is given with this coordinates. All right, so a lot of coordinates here. All right, we're going to dilate ABCD by a scale factor of 1/3 in order to find the distance of A prime D prime. Round your answer to the nearest 10th. All right. So my suggestion is find length first, then apply scale factor. That's just what I like to do. Technically, you can do these in reverse. You can apply the scale factor, but you might run into decimals, something quirky might happen, I don't know. And then you can find the length. This is just my suggestion. All right, so we're going to find the length of AD, x sub 2 minus x sub 1 squared, so on and so forth. All right. Now, maybe you want to pause the video here, and in fact, for this whole review, maybe you do this whole review by yourself and then check your work. That's probably a good idea. So like pause the video, try a problem, pause the video, try a problem, check your work, so on and so forth. All right, because you've already seen me do this. All right, we have to be at the point in time where you guys can do this yourself. But nonetheless, if you're still watching, the biggest thing is to try to avoid silly mistakes. All right, I plugged everything in very thoroughly, but notice how we have minus a negative, minus a negative. So in this next step, I'm just going to clean it up a little bit, not do any real computing, just write +9 and +3. All right, and then let's just be very tedious in what we do. All right, try to avoid all silly mistakes. so on and so forth. All right, I got the square root of 45. That's the length of AD. Now what I'm going to do for here is I'm not going to even plug it in the calculator yet. I'm going to say A prime D prime equals 1/3 radical 45, which can also be written as radical 45 over 3. But nonetheless, I'm going to wait till the last second to plug this into a calculator, which when you do, it should look like this. Because if you wait till the last second, you're going to avoid calculator errors, or rounding errors, I should say. We were trying to avoid rounding errors. And what's really important when we plug this into a calculator is that we have that parenthesis right there. All right, don't forget to close your parentheses. Or you could do radical 45, enter, and then divide the answer by 3. But nonetheless, it's going to give us a number 2.2. All right, so we're going to dilate triangle EFG by a scale factor of 2 from the origin, and then we're going to translate it using this rule right here. And technically, I probably should have that. All right, but nonetheless, let's go ahead and plot this triangle really fast. E is 2, -1. F is 4, -1. And G is 2, 3. All right, dilate by a scale factor of 2 from the origin, so that's the center we're stretching from, so we're really just multiplying all these points by 2. In fact, I can just focus on these points first. Say if I'm scale factor of 2, E prime is going to be at 4, -2. F prime is going to be at 8, -2. And G prime is going to be at 4, 6. All right, so let's see, 4, -2. F is 8, -2. And G prime is at 4, 6. And something I always like to do, just find satisfying, is I like to draw these lines that emphasize that we dilated from the origin. All right, and then we gotta apply this rule right here. Again, we can technically do this stuff without even looking. X, Y arrow, X -5, Y -2. All right, I just rewrote the translation, the second transformation we're doing. So I'm really just subtracting 5 and subtracting 2 from every point. So like, since I'm doing that, I know E double prime, what's 4 minus 5? -1. What's -2 minus 2? -4. F double prime, what's 8 minus 5? 3. What's -2 minus 2? -4. And then G double prime would be -1, 4. All right, that's it. We're just shifting everything so I can go ahead and plot these points. Or you could just straight up count from the graph itself. So -1, -4, 3, -4. So E double prime, F double prime, and then G double prime is at -1, 4. And that's it right there. All right, that's it for video 1.